says, please pay attention to this. This is just preamble. This is just a preamble. Okay. Okay, this is just a preamble. If a question says, take note of this. If the question says regress y, it means y is a function, oh, sorry. Yes, y is a function of x. That is, y is the dependent variable. Y is a dependent variable. Is the independent variable. Yx is what class? Independent variable. So when they say regress y on x, so mathematically, this is what it means. Mathematically, okay, it means y is equals to, let's say, beta naught plus beta 1x. Mathematically. Now, statistically, it means y is equals to beta naught plus beta 1x plus the stochastic term. This is regress y on x. That means y come first. So it is y on x. Y is a function of x, regress this on this. But if the question says, if it says the regression of x on y, let's take another one. Okay. The regression of x on y, the regression of x on y, the regression of x means okay, so that's what this means. Sorry, the network. So that's what this actually means. So either the question says the regression of x on y, okay, or regress y on x. The both is the same. Now take a look at that question. Let's go and solve that question.
Oh God. I'm gonna send video.
So we start with question number 5. Now, my first question to you is this. X is said to be regressed on y. They said estimate the regression of x on y. That means y is the dependent variable, and x is the independent variable. Okay, now take note. They said, is it true that restaurants near campuses with large student population sell more than those within the vicinity of students with low population? Now, Roman figure 3 says, what is the expected sales when the student population is 220 in thousands? Now, take note of this. All of these questions, okay, is actually, all of these questions are under the table. We are giving a table below, and the table gives us restaurants. We have 10 restaurants. Take note. They said Anthony Restaurant is a chain food restaurant located around the Akoka Yaba area. Do you understand? The managers believe that quarterly sales for its restaurant, okay, related as why, are related positively to the size of the student population, okay, in its vicinity. Now, how many restaurants do we have? We have 10 restaurants, okay? We have 10 restaurants. Now, student population in 1,000. Student population is in 1,000. So we have 2, which is X. We have 2, 6, 8 to 26. Then we have quarterly sales in thousands as well. We have 58 to what? To 202. 58 to 202. So when this question says estimate the regression of X and Y, what it's asking you is this. See what it means. Okay, this means, so we have, so the table is given. Let me first of all come up with the table. So we have, what's the one? Estimate the regression of X and Y. So just like we said, this means Y is equals to, you can use alpha naught plus alpha 1 X1 plus mu. So if you want to put this, you can put it. Okay, so what we are looking for is this. Y cap equals to alpha naught cap plus alpha 1 cap. So this is what we are actually, this is what we are estimating. This is what this question means to estimate this. Now let's go to the table. Now, quickly, I told us something very importantly. Whenever you are solving a question like this, okay, the first thing you need to do, quickly write out the formula. Quickly write out the formula, okay? Secondly, the formula will guide you on what to do, on how your table will be constructed. The formula will guide you on how the table will be constructed. I'm saying that again. Once you have the formula correctly, okay, the formula will be a guide on how your table will be formed. Okay, so I have this, for instance. Take a look at this. We have N. You know, the N there is actually the number of restaurants, which tells us the total restaurants in the Akoka vicinity. So this is N. So this is X. Remember, X is in 1,000, and then this is Y. Okay. Sorry, please bear with me. So X, we have 2688, 2688, 2688, 12, 16, 20, 20, 12, 16, 20, 20, 12, 16, 20, 20, 22, 26. 22, 26. 22, 26. So we are done with X. So let's take down Y. Let's take down Y. So Y is 58,105. This is taken from the table. We have 58,105, 58,105, 88,118, 88,118, 117, 117, 137, 137, 157, 157, 169, 169, 149, and this is 202. Okay. So the next thing, remember, we need to sum. We need to sum this. Okay. This is number one, restaurant one. This is restaurant one, restaurant two, restaurant three, restaurant 4, 5, 6, 7, 8, 9, and 10. Okay. Now, let's sum this. Please, somebody should sum this for me. Why somebody sum Y for me? Please, let me do that. Somebody should sum Y. Somebody else should sum X. While we're doing that, let me quickly give us the formula. So here, we expect alpha cap. Okay, alpha not cap is summation Y, summation X squared minus summation X, okay, 140. Please, somebody should confirm X 140. Somebody else should do Y for me. So summation Y, summation X squared minus summation X, summation XY, summation X, summation XY over what? N summation X squared minus summation X all squared. Then alpha 1 cap, this is the formula, N summation XY minus summation X summation Y. Thank you. Okay, they say Y is 1,300. Okay, so, okay, 2 persons have confirmed that. So Y is 1,300. So this is summation Y. X is 140. Thank you very much. Thank you, Chika. Thank you. Thank you, Ruth. So remember, please don't go and sum this one. This is just telling us that N is actually 10. Okay. Then, so this is the formula for alpha 1 cap. So we have this is over summation N, summation X squared minus summation X all squared. Okay. So now we have summation X, we've obtained summation X. We've also obtained summation Y. So we need X squared in our table. We need X squared in our table. We need XY in our table as well. So let's go there. So let's first of all do, excuse me, let's do XY. Okay, so please, 2 times 58 is what? We have 58 times 2. That gives us what, class? That is 116. 116. 105 times 6. 630. Thank you.
704.
704. Okay, 9 zone. So what is this times
944.
This is 944.
1404. 1404. Please, somebody should confirm.
1404. Okay.
2192.
2192. Are we there, class?
3140.
3140. 3140.
Yes, please. 3380.
3380.
3278.
3 what?
3278.
7. Somebody should be doing the addition, the last part.
5252.
5252. Oh yeah, please let me add. So we have okay, are we there? Okay, while somebody's adding, let's go to x squared. Let's have our x squared. X squared, this is 4. This is 36. This is 64. This is 64. This is 144. 16 square is what? What's 16 square?
Sorry, I'm totally XY.
Okay, 256. 256. 400. 400. 484.
The total of XY is 21040.
21.
040.
Okay, this is summation XY. So this is 676. 676. So please let me sum up x squared. Thank you, Boluwatife. Let me sum up x squared. Oh yeah. Let's sum up x squared, please.
Two five two eight.
2528. So this is summation x squared. That's summation x squared. So now let's check it. Let's go and check. I told you, okay, thank you very much, Abigail. Now, I told you that your formula will guide you, okay? We already know how this formula come about. So from here, this is summation x. Note, let me quickly write it for you. Note, summation x squared is not the same with summation x all square. It's not the same. This one means you square the value of x. The sum of squares of the value of x is this one. This one means the sum of x all squared is this one. So what this one means is that whatever this one is, you square it. What this one means is that you first of all find x squared. You now square each value of x squared. I mean, you now sum each value of x squared to get this. So this and this is not the same. So summation x in our formula is 140. Let's go there. Summation y is 1,300. You can see that my formula will guide me on how my table will look like. So I also need, so okay, this summation x, I already have it. Summation y, I've already gotten it. Summation x squared, oh, I have summation x squared already. Let's go again. Summation xy. Oh, I got summation xy. Let me come down again. What is n? Oh, my n. Even if the numbers are not given, just count from x. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Count the number of observations for X and Y. It will give you your number of N. So even if this does not give you, please don't go and add this. So don't add this. Don't add. Okay, so N is 10. Our N is 10. Okay, so please pay attention to this. Let's quickly do this together. What else are we looking for? Summation X squared, we've gotten it. So let's go ahead and solve the question. We are going to do plug and play. Let's solve Y cap first. So how do we do this for Y cap? I mean, sorry, for alpha naught cap. Class, for alpha naught cap. For alpha naught cap, this is summation, so this is alpha naught cap equals to summation Y is what? 1,300 into what summation X squared? Summation X squared is what? 2528 minus summation X. Summation X is 140. Okay, yes, summation X. This one means summation X. You will not square the value. Don't worry. We're almost there. So 140. What is summation XY? 21040. 21040. Close the bracket. Divided by, what is N? Our N is 10. Please do not add this value of N. This is to confuse you. Okay? This is telling you this is restaurant 1, restaurant 2, restaurant 3, restaurant 4. It doesn't mean 1, 2, 3, 4. Don't add it to. Like I said, you can ignore it and count the number of observations to know how many, what's the value of N you are dealing with. So let's go there. Our N is 10. Then summation X squared is 2528. 2528 minus, so somebody was asking that we did not have summation X squared. Now this is it. This one means that you put this summation X. What summation X? 140. You put it inside bracket. You now put square on top. That's what it means. Okay, I hope you are getting them. So, oh yeah, 130 multiplied by this. Abigail, give me value. Chika, give me value. 1,300 multiplied by 2528.
3286400.
3286400. Thank you. God bless you. Let's have this.
$2945600.
Okay, 294. Abigail, yeah. Thank you. 2945600. Thank you. God bless you. Let's have. Okay, this we just add the 0 to the front. Okay, 140 square is what?
19,600.
19,600. So class, so we have this minus this. What do you have, please? That should be 340,800.
Yes.
Oh, okay. 340,800.
56800. 8080.
5680, right?
Yes.
Thank
That's
you.
60.
That's what?
60.
60. Thank you very much. Abigail, thank you. I got that from the chat. Now let's go there. UK, thank you. So now we've gotten alpha naught cap. Now let's go and sort out. Let's sort out alpha 1. Now, how do we sort out alpha 1 cap? Alpha 1 cap is equals to, remember, this is the formula we're using. N is 10. N is 10. Summation xy is 21040. Okay, 21040 minus summation x, summation y, 140.13. So this is 140.13 divided by, so since the denominator is the same thing, there's no need doing it all over again. So this will give us 210.400 minus, please do 13 times 13 multiplied by
18,000.
114. Okay, 18,200. So divided by 5680. So please subtract the top. What do you have?
28,400.
We have 28,400. So divided by 5680. So what do you have, please?
Five.
We have 5. So now, remember they said estimate the regression of x and y. So class, the regression of x and y, okay, the regression, okay, of x and y. So remember we have y cap. So y cap what? Remember this from the beginning, I told us. So what is alpha cap? You know, this is alpha 1 cap. This is alpha 1 cap. So alpha naught cap, this is alpha naught cap. Okay, 60. So this is 60. The sign is plus 5x. So this is what you've been able to do. Okay, very importantly, this is what you've been able to do. Now, before you go ahead to interpret, check first the next question to be sure the next question is not asking you what we're about to do. Now, the next question says that, is it true that restaurants near campuses with large student population sell more than those within the vicinity of students with low population? Take note. What is that telling you? Because the question says Anthony Restaurant is a chain food restaurant located around the Akoka Yaba area. And the managers believe that quarterly sales for its restaurant are related positively to the size of the student population in its vicinity. In its vicinity. So this question is not saying, is it true that restaurants near campuses with large student population sell more than those within the vicinity of students with low population? Class, what is the answer?
The answer is true.
What is the answer? The answer is true. Because, see, from here, you already know that there is a positive relationship. If a restaurant has more students to patronize that particular restaurant, they will sell more than those that are actually within the school vicinity. Okay, so a restaurant with more student population, okay, it's tend to have more revenue, more sales. Okay, remember the other factors that can make students patronize the restaurant. But we are trying to say here, we are regressing Y on X. We're regressing quarterly sales of this restaurant on the student population. That is, the sales of this restaurant is a function of the number of students in school. So if more student patronizes you, you will have to, your revenue will increase. If the student is low, revenue decreases. So now let's quickly interpret this result. Remember that the student population is in 1,000, okay, and the revenue is also in 1,000. So now let's interpret this first. So you say the intercept the intercept coefficient, okay, is 60. Okay, this shows the average revenue, or sales when population is 0. Okay, or when there are no students on campus. Okay, now this is the intercept. Okay, in other words, sales, let's choose quarterly. In other words, quarterly sales will be what? 60,000 will be 60. Oh, it will be 60. Let me do it very well. It will be 60,000 naira. You multiply this 60 by 1,000. With 60,000 naira. Okay, if there are no students, or if there are no student population, okay, on campus. Also, let's go ahead and interpret for the value of the coefficient, slope coefficient. So it's okay. Also, the slope coefficient okay, is 5. Okay, which shows that quarterly sales is positively related to what? To student population. Okay, student population. Okay, this means that this means that a unit increase. This means that a unit increase, okay, in student population, will cause sales to rise by what? By 5,000 naira. You multiply the 5 by 1,000. Okay. So that is what it means. This means that the unit increase in student population, that if student population increases by 1 person, if 1 student joins the population, what is the contribution of that extra student on revenue? Is going to be 5,000 naira. Okay, let's go to question number Roman figure 2. It says that, is it true the restaurant, okay, Okay, sorry, please. The network has been so bad. So is it true that, so yes, it is true that restaurant with larger population, okay, will sell more than those with low population. Okay, because more population, more student population means more revenue or more sales to the restaurant. Okay, so the next question says, what is the expected sales when the student population is 220,000? What is the expected sales? So this one is saying you should forecast. This is our question like this will come. We should forecast what is the expected sales. What is the expected sales if the population is 22,000? So that means you're looking at X equals to 220,000. Remember this. Don't make mistake. Okay. Don't go and put X equals to 20,000. Okay. In this, work in your units. Then your final answer, you can multiply with 1,000. So you're going to make use of X. So recall we have Y cap equals to 60 plus 5x. This is what you're going to use. So the Y cap will now become 60 plus, don't put 220,000, just put 220 in the bracket. Use 220. Okay, use 220. So this will be Y cap equals to 60 plus multiply 220 by 5. I think that should be 1,100. So that's 1,100. So 1,100 plus, so this gives us, okay. So this gives 1,000. So Y cap gives 1,160. So this is what we're going to have. So if you now multiply this by 1,000, so this will now be, okay, this will now be, take note of this. Okay, let's take note of a few things here. This will be 1,160. So this will be the revenue. Okay, this will become your revenue. Now, alternatively, let's check it whether our answer will be the same. Okay, alternatively, we have Y cap equals to 60 plus 5x. Okay, so in thousands, we're working in thousands. This is Y cap equals to, this is 60,000. I want to be sure if we're going to get the same answer, plus 5 into 220,000. So Y cap equals to 60,000 plus, we have 220,000, 220,000. Okay, multiplied by 5. So it's correct. We have 1.1 million. So if you add it together, it's going to give you 1 million. Okay, 160,000. So it's is the same. Grows to 220,000. Sales will be 1,160,000 naira. Okay.
Elsa, please, I have a question. I don't know if you can allow question right now.
Yeah, please go ahead.
All right. So when we're talking about the slope coefficient is 5, you mentioned that it means that for every unit increase in students population, it will cause sales to rise by 5,000. So coming back to this formula where we have y cap equals 60 plus 5, how are we not assuming the 5 to be 5,000 instead of, why are we making it just 5 instead of 5,000?
Okay, this is it. This is it. Now remember that the student population is in 1,000. The student population is in 1,000. The revenue, the sales is also in 1,000. Whatever you are doing, you must have that at the back of your mind. So I will say that if student increases by 1, if student population should increase by 1, that 1 that will mean a unit is actually 1,000. Do you understand? If the student population is measured in 1,000, it means that unit increase is actually 1,000 increase if student population increases by 1,000. But I cannot say if student population increases by 1,000, okay, that sales will increase by 5,000. No, but rather, if student population increases, a unit increase is saying that, okay, a unit increase is equivalent to 1,000 students increase in population, because student population is in 1,000. Do we get the gist now? See, always take note of that. Anytime you are doing interpretation, you have to go back to the question. Look at the units of measurement. If the unit of measurement is just, if it's silent, it should have just been a unit increase in student population will cause sales to increase by 5 naira. But that would have been it. But because the question has already stated there that student population is in 1,000, any increase in sales will be the number multiplied by 1,000. Okay, are we there? So that is why this comes to 5,000. Any question again?
I get what you're saying about the 5,000. So what I'm saying that using this something you said now,
okay,
when we are looking for the y cap, as in for the question 3 that is asking at 220,000, what will be the revenue, the sales revenue at 220,000?
Yeah.
So my question is, why are we not now representing 5 to be 5,000? Instead, we're just making it to be 5 times. Why are we not saying 5,000 times 220?
No, you cannot say 5,000. See, this is, what we had from our estimation, alpha cap is 5, not 5,000.
Okay.
So do you understand? Alpha cap is 5, not 5,000. And this is how you estimated this square line. So this is what we are using.
All right.
X is in 1,000. Y is also in 1,000. Are you clear now?
Yes, I am.
Okay. Any other question, please? Okay. In the absence of that, let's move on to something else. Let me quickly share some things with us.